So the last exercise had me thinking, you know what? That was a lot of extra work to figure out that debugging of how do I get, the structure of the tree. Especially when you move into binary search trees that are balanced, it can be really tough to figure out what your tree currently looks like and where it should go and how do I balance that tree. So let's kind of on the fly here build a little helper method. There's a lot of times in software you build code just to simply help your own understanding of the problem. It might be throwaway problems. It might be stuff just for testing. It might be stuff just for maintenance and management of stuff. But it's often useful, and so you should never feel shy about writing and adding to your code to better understand what's going on inside your code, to improve your mental model of what's happening inside your code. So I'm going to build a function here. I'm going to add it in. And I think I'm going to actually add this in as part of the interface too, and let you build this for points later on. But it's going to be a public method. It's not going to return anything. It's going to do a print the structure of the tree. It's entirely for debugging purposes. I could build it as a string and make it reusable, but I'm not going to worry about that for now. I'm just going to use system.println, keep it simple. Um, so really what I wanted to do essentially is, if I have a tree that the root is let's just say the root is H, and it has the left node of an E and the right node of a U, and then the E has a left node of a and the right node of an F, and then the U has a left node of a I don't know, an S and the right node of a Z. So there's a little tree going on, and that would be show me some structure of that. It would help me know. So yes, H was added first, but it doesn't necessarily mean after I remove things, after I balance the tree, what could be different. So it'd be nice to print out something like that. So how do we do that? Well, I can't do it entirely recursively. The traverse algorithms doesn't give me a left me right or right me left or me left right or whatever those options to manage that. So I have to actually combine both recursion and looping in the traditional sense. And so it's the most efficient algorithm, but it's going to be a very helpful algorithm. So I think the way I can do this is let's start with let's get the height of the tree. We'll just call it H for the lack of a better term. So we'll get the height of the tree. And so what we can do is we can essentially build the height of the tree by printing out each level at a time. So we print out the root, then we print out all of these ones below the root, which we could do on our own. But then what we can't do is when we get down to the level below that, print out just that level, unless I have some sort of way of doing that. So the height essentially starts at 0 and moves its way up, or we can start at 1, move our way up, however we want to indicate that. But let's loop through this. So for int I is equal, let's start at level 1 and go to I is less than or equal to the height, H, excuse me, just H. And let's go print each level one at a time. So as we saw before, the height of the tree, the level of the tree, the depth of the tree, if you will, is what we're going to look at. And so then for each that, let's print the given level of the tree, starting with the root in this case, and going to I, that level of the height. And then we don't know. So then I think probably what I'm going to have to do is do a system.out.println here at the end, just to show that that's the end of the row. So basically the idea behind this is if the tree is size 1, I print height 1, which just prints the root. And then from there I go down. If it has the next level, I print the next level, height 2, which then prints all below it, and so on and so forth. So hopefully you can see the structure of the algorithm I'm considering. So this is my base structure of what I'm thinking is, the tree, I print it one level at a time all the way down. So what I need now is a helper on that, which is, I can make that one private. I don't think I need to return anything on this one because I'm just printing. So this is what I called print given level. And it's going to take a node, which is going to be the subtree. It's going to print. And it's going to take the level it's going to print out. I don't know if I should do 0 or 1, but in my head, starting at level 1 makes some sense of going up equal to the level H. And I think it probably doesn't matter one way or the other. All right, so if there's nothing here to print, so we always start off the base case. So if the subtree is equal to null, well, I don't necessarily need to print anything, I think. I can just probably just return at that point. I don't have to do anything. I might print something, but let's see what this looks like when it gets printed out and go from there. Um, so we do want to identify the root of this. So the root, we said it's going to start at level 1. We probably could have done it at 0 just the same, but it doesn't matter. Again, I like the idea of level 1 because it aligns to what we were talking about in the trees. Either way it could work. But let's say if the level is equal to 1, as I said, it could be 0, it could be 1. Then let's do a system.out.println that the root. Okay, so that's going to be the root right here. And I want to root, it's going to point to subtree.value. Print out that value. I'm going to mark that as the root right there. So that way it's super clear that that one is the root. All right. So if it's not level 1, well, it should be higher. I mean, I could test for lower, but it's just not bright bad code. Well, then what do I want to do? Well, I want to print the given level for the left root, the subtree.left, right? And the subtree.right. But I probably need to adjust the level, otherwise I'm just calling myself again. So again, we're starting at level 0 when we print that one out. Then we go to level 1 and print that one out. So I think what we need to do is, like, let's say we do level 7. Well, I think I need to shrink that by 1 each time. Let's see if that's what's going on there, because they should increment or decrement by 1. I don't want to go up. So I want to print. So I only want to print when it's my turn, when it's my level. And so if I have only a tree of 1, then I print in a level of 1. If I print in level of 2, well, I'm going to move up, 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 up the tree, and it's going to actually move down, 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 down the levels. So I could also define this backwards, but let's give this a shot. Let's see what this does. So right now I haven't actually called this anywhere. I need to find some place to call this. So let's talk, let's figure out some place that you might be doing some debugging. Let's just say you go to your test cases. So you're in test cases and you wanted to work on, here, let me go back to the tree test. When you're removing, let's say, you're having a problem with your tree structure, you're not sure how it's doing when you're moving. So you would say, let's start this by saying print tree structure. Sorry, let's see. So I need UUT. Yes. So as we're moving each time, let's say in this loop right here, we're going to do UUT. That's unit under test, if you didn't know that. Dot. Oh, I have the wrong. So I do have to add it to my set here, by the way. That's because my interface won't work otherwise. So I'm going to say print structure right here. I'm going to add this to my simple set right now. So that way I can see it, because if I don't do this, I don't know which one I'm testing. That's going to actually cause a problem over here, but we can ignore that for the moment. So we'll come back to my tester and say print structure right there. And so when I do the remove test, it's going to show that tree structure each time. Let's see what happens here. We'll go ahead and proceed there. All right, so let's see what happened here. Oh, it only printed out the root. So there's something I did wrong in my structure. Uh, hmm. So I need to debug this. Um, let's see if I can get a quick sense of what happened here. Um, oops. Simple tree set. I'm going to use debugger real quick. And let me do this. Sorry, I'm going to ignore that error for now. All right, so when I print this in, I come out at level 1, so I don't care about that. Let's just run that along. Okay, now I'm at level 2, so what's happening here? So I step over this. Why is it not showing me the update here? I'm confused about that. So it does come down to level 1. Oh, you know what? I can't say root every time here because that's when it prints it out. That's my bad. So let me take that out. And let me not do a print line too. I need to do a print. That's two bad things I did. That's two mistakes on my part. Um, hey, it all happens to the best of us. Because remember, I want to print these all on one level, so these are actually all showing up. So let's terminate this and let's run this again. So I think my logic was right. My formatting was bad. All right. So I have Q, LV, A, Q, LV, Q, Q. So this one's not necessarily the best example. But what I can do to make my example better, let's go to my tree here. Um, and let me change where I add this in. So let me, the remove actually isn't, there you go. The remove isn't the best example because I'm not building that big of items right there. So let me do the add. Um, yeah, because I'm only doing 5 items there, but let me just do the add test. That'll show us a little bit better, just to really give you a feel for what's going on here. So after I add it, let's do uut.print structure right here, and we'll see this in better form. Yeah, so there you go. And I might want to put some space inside of there as well. But you can see we have O, 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 skip S, S, O. So we can probably format this a little bit better by putting a space inside of there. But as we get bigger, um, we can see now we're starting to see O as the root, the ls that comes next. The ERU is underneath this, and if we put some spaces, we can maybe format this a little bit better and have it show. But now OLS ERU, and then underneath that BTW. So we're adding in some more values. At BTW, BPTW, you can see these values getting added in. So it's a little bit of some structure to help us understand our code more and more and more. All right, so here's a second freebie. I'm going to add it in for extra points. You can follow along. Basically, what this is going to do, oops, sorry, as I'm just going to clean this last bit of this up. Print structure here. So let me print this plus a space. There you go. That you know what? Let's actually do a between that. So let me do this one more time, and we will see a little bit better. Yeah, so there's a lot better now. Now we can see this tree structure much better now. So let me make this big. Um, so we have a D in a tree, and then D in a tree, nothing gets added. I'm sorry, D in this tree, and then D with L underneath it. Then D with L underneath it. You know, if we actually probably could add in the print of what's getting added, the debug of what's getting added in each one. But then now you can see a DL with an HY underneath it. So the it's showing you the hierarchy of the tree as it grows up bigger and bigger and bigger, and shows you as things get added in. So this will be a useful debug method later on, as we're adding in more and more items inside of here. You can see you get a tree that's pretty big, a D with an A and an L, and then a C must be to the right of A, and so that means this L must be the right of the H, and so we can really start to get a feel for what the structure of the tree is. It's not perfect, but it is a nice way to be able to practice navigating trees, writing code in trees, and some free points for you as well. So have fun with this. I hope that you do find this useful if you go off and build it. If you have some tips or feedbacks on making this even better, let me know, and I'll give you even some bonus points on that as well. And we'll go from there. So thanks, and have fun with this.